Hey everybody, we're going to actually pick up right where we left off from yesterday, and we're going to be solving proportions again today. More specifically, it's going to be like the word problems where you're going to have to set up and make sure that things are organized. So let's go ahead and take a look. So our lesson for today is 8.5 on similar figures. Our learning target is I can solve problems involving similar figures using proportions. This is exactly the same thing that we did yesterday when we were solving our word problems. So similar figures are figures that have the same shape but not necessarily the same size. So if you take a look at my example, I have two separate triangles there. One of them has side lengths 3, 4, and 5, and the other one has side lengths 6, 8, and 10. I know right away that those are similar, and here is the similar symbol right there. It's like a little wave. Now the reason I know that those are similar is because if I compare the side lengths, look what happens. Take a look at my numbers right here. If I write those side lengths as ratios, they form a proportion. 3 to 6 is equivalent to 4 to 8 is equivalent to 5 to 10. So we're going to use our side lengths to test to see if figures are similar or not. So let's take a look at our first example. Determine whether these polygons are similar and then make sure to explain why. My first example, I have a triangle 3, 4, 5, and I have a triangle with side lengths 5, 12, and 13. Now, just like yesterday when we were solving proportions with word problems, we want to make sure that this is organized. So the first thing I'm going to see, I got 3 and 5. Notice how those match. So I'm going to write those down as a ratio. Okay, next I'm going to pick 4 and 12, and I'm going to write those down as a ratio. And then the last one I'm going to pick is 5 and 13. Notice that those match, and I'm going to write that down as a ratio. So I want you to look at those ratios, think of those as fractions, and decide, are those the same? You could also simplify them. You could also do your cross multiplication like we did 2 lessons ago to compare the numbers to see if they're the same. You'll notice right away that those are not equivalent ratios. Therefore, these are not similar. And they are not similar because the sides do not form a ratio. Let's take a look at number 2. All right, this time I'm going to pick, let's use 6 right here and 8 over here. And I'm going to pick this other diagonal, 6 and 8. So right away I know that those are the same so far. So really it comes down to our last one. I need to know if 8 and 12 also matches. All right, when you are looking at those ratios, there's a couple different ways you can do this. You could go ahead and you could simplify them. You could also cross multiply. Now, if I simplify these, I know that this one over here, these ones right here are 3/4. This one's 3/4. This one right here is 4/6, which is 2/3. So that means that, no, these are not similar either. And they are not similar because the sides do not form a ratio. All right, now what happens if they tell us that my triangles are similar, my shapes are similar, and we're looking for a missing side? So this is just like setting up a proportion when we were doing word problems. So the first thing I noticed right away in my 2 triangles is I'm missing this side right there, labeled N. And that's going to actually be my first thing that I'm going to label or put into my proportion. Now, the next thing that I'm going to do is I'm going to find that exact same side length on the other triangle. And it's right here, it's 4. So I'm going to put a 4 underneath it, okay? Now, on the top of my proportion, I need to pick a number from my big triangle because that's where the N is, and the N came from the big triangle. It's like yesterday when we set up and we made sure that miles were on the top, okay? So the big triangle's on the top, I need to keep it on the top. And I can pick whatever number I want, it doesn't matter. I'm going to pick 15. Now, since I chose 15, I chose that side, I need to pick the corresponding side from the other triangle, which in our case right here is 5. Now I can go ahead and I can cross multiply and divide to finish my problem. 5 times n is 5n. 4 times 15 is 60. Divide by 5 on both sides. and n equals 12. And my label, I think, is meters. So that missing side length was 12. Okay. All right, let's take a look at number 2. Ooh, this one's a little tricky because they're trying to trick us and they did some rotating here. So let's take a look at our triangles. First thing I notice is this side length right there is missing. So that's going to be the top of my proportion. Now I need to find that exact same side on the smaller triangle. And you'll notice that it's just rotating. The triangle is rotating. So the matching side is this 3 right there. Now I can go ahead on my bigger triangle and I can pick whatever side I want again. I'm going to pick 35. I don't know why, just the one that I picked. So that one's going to go on the top because I need to keep it organized. And then the matching side, notice again that it's rotating, that's going to be the 5. So the 5 is going to go on the bottom side of my proportion. Now I can go ahead and I can cross multiply and divide. 5 times n is 5n. 3 times 35 is 105. We're going to divide by 5 on both sides, and n equals 21 feet. Now, solving for missing side lengths in triangles and other shapes is really great when you're taking a look at pictures and you're doing some word problems. So let's take a look at 2 more examples. I'm going to use proportions to find my missing measurements. So it looks like I'm measuring the height of a tree in a geyser and then the shadow. So the first thing that we notice is on my tree here, I'm looking for how tall that tree is. So that's going to be my x value. So since in my first ratio I have how tall the tree is, I want how tall the geyser is, which is 60. Now the other thing that I can measure is the shadow length of the tree, which is 63, and I'm going to make sure that I put that on the top so that the tree information is on the top and the geyser information is on the bottom. The shadow geyser is 42. Now I'm going to go ahead and I'm going to cross multiply and divide. So 42 times x is 42x. 60 times 63 is 3,780. My next step is to divide. I'm going to divide by 42 on both sides. And I get x equals 90 feet. Might be a good time. We only have one problem left with Garrett crying in the background. All right, let's take a look at number 2. Looks like I'm measuring some distances around a river. So I'm looking for the distance across my river. And that side is going to match with my 16 over here. Now the other information I know is I've got this 42 right here. I don't know what they're measuring to, maybe to like a dock or something. So that one's going to go on the top because that's for my bigger triangle. And then I have 18 meters, which is from my smaller triangle, so that one's going to go on the bottom. Now we're going to go ahead and we're going to cross multiply. 18 times x is 18x. And 16 times 42 is 672. Now we can divide by 18 on both sides. And x equals, I'm going to use my calculator. Ooh, I don't know if I got that one right. That looks wrong. Let me double check. Yep. Okay, so we got 37. I got 37, and I'm going to go a third because it was 0.3333 repeating, which is 1/3 meters. All right, there's our lesson for today. That one was a little bit longer too, but it's all about setting up proportions and solving them. Make sure that they're nice and neat and organized, and you'll be sure to get the right answer because the cross multiplying and dividing is pretty easy. You do have a couple IXLs to do. I feel like I took one of these away, but I don't know off the top of my head, so please make sure that you check the weekly to-do list or the IXL sheet and make sure. I think I took one of those off, so please double check before you end up doing all 3 of those. As always, send me a message on Schoology if you need anything. Peace, guys.